So today I'll be doing a quick tutorial on SUVAT, just basically going over exam technique, how you should approach questions to do with SUVAT, and also just generally going over a few misconceptions. So the question I chose was from the Year 1 Mechanics and Stats book, Chapter 9D, question 14. So I think it means it's come from an exam. So I'll just get straight into it. Two particles P and Q are moving along the same horizontal line with constant accelerations 2 meters per second and 3.6 meters per second squared, respectively. At time t equals 0, P passes through point A with speed 4 meters per second. 1 second later, Q passes through A with speed 3 meters per second, moving in the same direction as P. Okay, so it's asking, write down the expressions for the displacements of P and Q from A in terms of t, where t seconds is the time after P has passed through A. Okay, it also asks to find the value of t where the particles meet, and also to find the distance of A from the point where the particles meet. I want to focus on part A because B and C are relatively easy once you've got part A. So whenever you're attacking an exam question, you need to have a goal in mind. The goal for this would be expressions for displacements. So if you think to SUVAT, it's going to be something along the lines of S equals, because S is our displacement. Okay? So before we get on to looking at the information given to us by the exam, I want to look at our checklist for SUVAT. So these are 4 things that I always tell my students that they need to know or remember when doing SUVAT. So you obviously need to know the equations. Okay, these are them here. If you don't, if you want to pause, look at them, that's them there. You should be already familiar with those. Then the assumptions. Well, the assumption is that it's constant acceleration and also that it's one-dimensional, meaning if you have a projectile, you have to resolve horizontally separately to the vertical direction. And then these 2 last ones, the 4th one is relatively straightforward. You need to know your start and end point, otherwise you won't be able to fill in your SUV or A or T. But the 3rd one is a bit tricky, and you probably have seen it. You probably are doing it without knowing it. But I'll explain what that is when I get to the question. All it is you're defining positive direction and you're defining where 0 displacement is. Without those 2 things, you don't have a frame of reference. So let's get back into the question. So I'm going to start off by converting the information from the question to my exam paper. Okay, and I'm going to do that with a diagram. So I know that there is a point A. So we're moving in one direction. I'm going to go from left to right because it says horizontally. And this brown line is point, this is A, okay? Then we need to draw on the particles. So we have particle P at A, okay? And we can add on particle Q. Now we know that particle Q is slightly behind particle P, so I'm going to draw it there, okay? And then I'm going to draw on the accelerations and the velocities. I'll start off with velocities. Here we have an initial velocity of particle P, so that's particle Q. We have initial velocity of particle P, which is 4 meters per second. 4 meters per second. Now, in this position, it doesn't actually tell us what the speed of Q is, but it does tell us the speed of Q when the particle Q is over passing the point A. And at this point, because they're both moving to the right, I know that P is over here somewhere, and I can also draw on the vector there. This says it's 3 meters per second when it passes the point A, and this has some sort of velocity, we don't know yet, and this also has some sort of velocity. So that's our situation. The only thing we need to put on is the accelerations. So this acceleration of P here, so I'll just do it here, double arrow for my acceleration. Okay, my double arrow for my acceleration for particle P is going to be 2 meters per second squared, and the acceleration for Q is going to be, I'll draw up here because the acceleration is constant. This acceleration says it's 3.6 meters per second squared. Okay, so we've got 3.6 meters per second squared, 2 meters per second squared for P, 4 meters per second when it passes point A, and 3 meters per second when Q passes point A. So now we've got the information all converted to the paper, we can have a look at what is going on. So let me just add another detail. This is when t equals 0, and it's important for us to, at this point, remember that third bullet point in the SUVAT checklist, which is frame of reference. Now, frame of reference is where we define the positive direction. I'm going to define positive direction to be going to the right. This is the positive direction, but also I need to define where 0 displacement is. I'm going to set 0 to be here. So Q in this position over here is going to be a negative displacement, and the displacement of P over here, I've got to label that, P over here is going to be something positive. Okay? Any arrow pointing right is going to be positive. Any arrow pointing left is going to be negative. And that's really important. So now we can get to thinking about the question a bit more, because now we've converted all the information onto our page. So now we need to think about, okay, we need to write down expressions for the displacements of P and Q from A in terms of t, where t seconds is the time after P has passed through A. Oh, I forgot to put this information. This is t equals 1. Okay, good. So now we can get to the part where we start doing actual SUVAT. So we're going to have our P SUVAT, so SUVAT, and we'll have our Q SUVAT over here, SUVAT and T. Now, what the question is asking us is an expression for displacement. So that's kind of our answer. So I'm going to put a question mark on the S's, okay? Because that's what we want to find out. So that's one of the parameters. Now, if we need to also think about our start and end point. So I'm going to focus on particle P. I'm going to do particle P here. This is particle Q. Alright? So I'm going to focus on particle P for now. So the initial velocity of particle P, well, we need to think about where it starts. It starts at A and it finishes somewhere along the right. So it starts at A, so we know the velocity is 4. So I'm just going to put a 4 there. The other parameters that we know are going to be the acceleration. We know acceleration is 2. And we also know, because this question is asking us for an expression of displacement in terms of t, we technically know t, and the value of t is little t, okay? So that's just representing an arbitrary time after particle P passes point A. So we've got 4 out of our 5 parameters. That means we can create a SUVAT equation. Now, doing the same for particle Q over here, we need to think, okay, what's our start and end point? Well, my start point is going to be here when particle Q passes the point A, and the end point will be somewhere else, okay? Because I don't actually have enough information for particle Q over here. And anyway, it makes much more sense for us to do it over when it passes point A. So when it passes point A, the initial velocity is 3. We know its acceleration. Acceleration is constant, so it's going to be 3.6. And we also know the t. Now, when it passes point A, t is not going to be the same as here, because t equals 0 is this top situation. This bottom situation is a different situation, which is 1 second later. So that affects what we put for t here. Now, since Q passing A is 1 second after P passing A, I'm going to write t minus 1. Okay, so that just explains to us that Q is passing point A, which is our start point, 1 second after it passes, 1 second after P passes point A. Because we're using the same variable, lowercase t here, they're connected. We can do cool stuff with that later in the following questions, but we do need to have that minus 1. Now, if we think about, so now we can kind of forget about the diagram, we've moved on. Now we've just got to think about the equation we're going to use. Now, we've got 4 out of the 5 parameters, and I know it's going to be s equals ut plus half at squared. So I'm going to write that down for P. So P, maybe I'll do it in a different color. I'm going to do it in blue. So let's do it in blue. So I've got P now. SP, so that's displacement subscript P equals ut plus half at squared, which equals, well, ut is going to be 4t plus half a, which is 2t squared. That just equals 4t plus t squared. So now I've got an expression for the displacement of P at time t. Okay, do the same for particle Q. Q, S, Q equals. So it's going to be the same, ut plus half at squared. Substitute our values. Our values that we're going to substitute are going to be, well, they're going to be ut, which is 3t. Actually, no. T, remember, is actually t minus 1. So it's going to be 3u brackets t. That t is actually t minus 1, because it starts 1 it passes point A 1 second afterwards. So you have to put half brackets A is 3.6 brackets t squared. Now t is the same, t minus 1 squared. So now that I'm going to just simplify that. I'm going to say equals 3t, I'll put it in brackets, minus 1 plus 1.8 brackets t squared minus 2t plus 1 brackets and then we can even simplify that even more. 3t minus 3 plus 1.8t squared minus 3.6t plus 1.8. So we've got t there, we've got t here, got 1.8t squared, then we've got t's, so that's going to be minus 0.6t, then we've got the numbers, so that's going to be minus 1.2. So now we've got an expression for the displacement of Q. And that, oh, you didn't even see what I was doing. That is what I was doing, okay? So, just to have a look here. Going back to our diagram, just to reiterate why we need t minus 1 here. If we didn't have t minus 1 in this, then we wouldn't satisfy our diagram. Our diagram wouldn't be correct. Okay, so if we were to do ut plus half at squared with just a t, if t equals 1 when q is passing point A, then that would have a non-zero value. But we know that displacement at the point A is 0 because that's how we've defined it. Therefore it's a contradiction. So we need this t minus 1 in order to satisfy the equation. I hope that makes sense. The next questions just involve you saying, so this is for question B, it's asking you to find where the time of t when the particles meet. All you would need to do is you'd need to say, okay, well, when SQ equals SP, so the displacement of Q equals displacement of P, clearly that's the point where they meet because they're at the same displacement, they're going to collide. And then for the question C, all you need to do is substitute that time that you find back into one of these equations. Doesn't matter which equation you use, it'll give you the same answer. So and I think the answer is t equals 6. So you just substitute t equals 6 into either one of these equations. And then you should have your answer. Okay, thank you.